Hello. Good afternoon. Nice to meet you all. And I hope you're enjoying the session so far. Yes? Yay! Yay! Yeah. It's my first time visiting the city. I'm really excited and very happy to join this conference and share my experience with everyone. Hope you have a good 40 minutes for my conversation. A bit about myself. My name is Teresa. I work for JP Morgan as a software engineer. If you came from UK, you probably heard or tried our product of Chase banking app. If you haven't, if you can try, give it a try. It really works really well because I'm a part of the team who built it. Apart from work, my other role is I don't get paid for it. I contribute all of my time into give talks in conferences. I'm a Google developer expert. It's a very nice community, tech community. You have GDG group in many places. I'm one of member in the community. So yeah, I also use a lot of Flutter and Dart in the past. But today, we will not talk about frameworks, but we'll talk about DevOps. But we will talk about DevOps in a very specific area for front-end projects. It's actually very different from building DevOps in cloud, and you will see why. I will explain it. So before we kick off, I'd like to I give my introduction. I want to actually meet all of you as well, but unfortunately we have 40 minutes, so I couldn't ask each of you to introduce yourself. So let me just see my audience and know you. How many of you here work for front-end project? Wow, awesome. Do we have any DevOps cloud engineer here? Great. We have a very good mixture of people from different backgrounds. So I assume you are either for people who didn't raise up your hand, I'm sure you're probably from other tech products or other areas, maybe AI. So let's begin. Right, a bit high-level view of the role of DevOps. This is actually DevOps definition for the entire world of in cloud. DevOps, what does this person do, right? So in the very, very beginning, I don't know, maybe 20 years ago, there isn't this role of DevOps. It started with you have a developer team, and once developer team spent 6 months building application, they will give this application to the operation team, and they will test, pack, and they release this application. But along with the innovation, along with Agile, DevOps becomes actually a role, and we have proper definition for it. And this person or this team will look after development, operation, make collaborations happen in the team, reduce the soil, and make things very automated, including testing, continuous development, continuous integration, and in order to make the team agile, accelerate and improve the overall productivity. And if you want to look at even further of how we implement DevOps in our project, if you have a large-scale product, this one is actually, I took this picture from Google. So if you look at each of the implementation of each of those functions, it can be actually quite complicated. It's about having a CI/CD platform, looking after your cloud infrastructure, make sure it's secure, and run the build and deploy this image to somewhere to host your web application, or deploy this to your app store to make a new release of your mobile application. But when we want to apply similar, let's say, pipeline into our front-end project, this will be slightly different, or maybe actually very different. But to make this simpler, right, for the entire DevOps world, where we can compare this to our front-end pipeline later on. This, if we think about DevOps and how we're implementing it in the end, it's all done into a pipeline, right? So the pipeline overview here, we always want to get the source code from somewhere, maybe GitHub, right, or any place. And we trigger this build by some trigger you define, automate by evening, by nightly, by a pull request. And this will be, we make the build, and the image is pushed to somewhere, right? Your container, your host, your registry. And all this will get used by the end user. So what does DevOps mean for front-end project? In your team, in your front-end project team, do you have like a dedicated engineer or dedicated team look after your pipeline? No, how do you do it then? How do you manage your release and your pipeline? So someone from the feature team has to spend some of the time managing it, or you don't? Okay. And this is a rough, basically, what DevOps role means for front-end project. For myself, I always worked as a front-end engineer. I spent a lot of time building a beautiful UI. But then for one of my projects in the past, because we have a project, it's a fintech product, we support different platforms, right? iOS, mobile, web, and we are even thinking to expand this to even more platforms. After a few years of 2-3 years of managing this product, we realized actually the bottleneck of this product is at release. So we actually have a very good team to build the features, and we have very innovation ideas. But when it comes to release, it was always a pain. Do you agree with me, or do you feel same painful process in release? This is then I'm the lucky one to be identified or to be chosen to be the tech engineer, to be part of the release team, to help them identify the issue in release and to improve it. That means we have to spend a lot of time writing script, Bash, Python, Groovy, to improve our pipeline, to make things automated in terms of the pull request process, the testing process, then look after the entire project architecture, and overall, this will contribute to improve our release management. And I'm going to share you all my study and findings in the next few slides. We'll talk about them one by one. So the CI/CD pipeline and the DevOps for front-end project is actually a lot simpler comparing to a cloud project. Because if you work in DevOps or having this role of platform engineering, core engineer, infrastructure engineer, especially for front-end product, you don't have to manage the cloud environment. You don't have to set up the container, you don't have to set up the security. All that should be taken care of by the cloud side of development. In the end, what we do is to look after the pipeline. So that means we will pull the code, testing it, deploy it, release it, and get feedbacks to operate. And this will contribute back to the life cycle of your product. So this is actually a lot simpler. The process itself is actually very simple. But if you're thinking about the difficulty and the complexity to develop and manage release of a mobile application release process is a lot more complicated than a web application. But we want to support as many platforms as we can, but we don't want to do them separately. So all this will add up to the end where our release process is actually very painful. So when you, in your project, right, I don't know if you use those tools, you can build your pipeline in a very manual way. Or you can use some of the tools, right? For example, Jenkins is open source, or you can use some commercial products like GitHub Action, GitLab, Berise, or Code Magic, right? If you are coming from the side of Flutter, you might be familiar with Code Magic. So those are the tools you can use. They pretty much do similar things, have very similar features, depends on what you need and what you require. You can choose to use them, or you can build everything in your own. But they have the reason that you want to use them because they have pre-made functions. For example, deploy it to App Store, get your code, sign it, right? So those functions are pre-made, so you don't have to rewrite them again. How do you choose those tools, right? Depends whether or not you want to have open source project, the cost, right? How secure you want this to be? Do you want to have a tool that you can easily adapt to a different tool? For example, if you are using Jenkins, your pipeline script will be in the language of Groovy. And in the future, if you want to move to, for example, GitHub Action, you might have to change the pipeline structure, the pipeline code into YAML style. So think about the cost when you decide to choose a tool, and the possibility that in the future you might move to a different tool. And it's still fine. It doesn't take a lot of time migration, but those will be some additional cost or time consideration as well. And yeah, do you want to host them locally, or do you want to host this on cloud, right? This is up to your team to decide, and your product requirement as well. Some projects is quite strict of how much we can go into cloud. Okay, so in terms of pipelines and how we should design it. Now we're going back to the word of front-end, right? So from here, when I say DevOps pipeline design, it's all associated with your front-end project. There are different pipeline style and different pipeline design we can have. And those are like 4 major groups, right? It doesn't mean you have to use all of them, but it would be nice if you separate your pipeline into those kind of groups because they do different things. And in the next few slides, I will go through each of the pipeline design and the pain point for each of them, and how we can actually contribute to improve it. So integration, you might call this PR process, right? So this is when you make a pull request and you want to merge your code to the main branch. And things that we can do here, right? We can think about different strategies. And you might have a full pipeline. That means you do a lot more tests, right? Other than just some simple unit tests. You might decide to do more tests covering everything. And this pipeline will run a lot longer. And again, if you are building a web application, your release and deployment pipeline might be the same one. But if you're doing a mobile release, your release is separate, should be separate from your deployment. And we will see why. Okay, sorry. And the reason I spend a lot of time studying pipelines and release management is because we've seen those pain points in the front-end project. Let me know if you agree with me, right? Now it's time to raise your hand again. Do you feel painful when you want to test your code and think about why you should test, why you shouldn't test? So is testing a painful process in your project? Thank you, because nobody raised a hand. I was really admire how you manage your project, because I want to learn from you. When it comes to release, do you cut release branch? And do you always release on time? Or do you have this release branch, which is long-lived, and you always have delay when you want to release something? Right, so we all agree this painful and a common issue for most of us here, which is great. I'm happy now. And how long do you have to wait to run your code to merge your PR? 10 minutes? 20 minutes? Half an hour? Or even more than 30 minutes? Yeah. Is your project a monolith, or do you think your project is micro front-end style? Do you find errors, or in your pipeline you do send a notification to people by email, by Slack message, by some integration, but nobody cares because they're all ignored, or people even put a filter to filter out those messages coming from your sensitive pipeline, right? So they are just ignored. So I think those are painful points for me, and maybe even more. So you can let me know after this conversation. We can discuss it, and you can add more to the list. So maybe in the future, we can identify how we can solve it. Right. So pipeline design and how we actually can accelerate those things associate very, very closely. Actually, they work together with how you architecture your project. Is your project micro front-end? And how is your release management? What is your branching strategy? And how do you do tests? And do you support multi-platform? Is your project a monorepo? So those are questions for you to think about, right? It's not just one of the person in your team building a pipeline which runs like 5 seconds faster because they used a better language rather than Groovy. It doesn't work like that, right? So those things all comes together. So how healthy your release management are is a reflection of how well your project is designed. So let's walk through those pipeline structure and point together. Let me see my time. Okay. Right. So pull request. The recommendation by Google for a pull request to merge your code to the branch is around 10-20 minutes, but it's really hard to achieve, especially for front-end project because of the testing, especially when it comes to mobile. We have to test things on different devices, different screens. And it's really, really difficult to run them in 10 minutes or 15. So in reality, pull request can take even longer than 30 minutes. Sometimes it's okay, right, to take an hour because how many tests we want to cover. So for those of you raise your hand, for 30 minutes, it's actually fine. It's average. So I think issues or problems that PR runs like an hour to merge. If you have a team of 60 developers or even bigger, having everyone to make at least one pull request a day, and having to wait for other people to merge first and solve the conflicts was really a painful process. And one thing here I like to discuss is the fail-fast solution. Have you heard or have you designed this in your PR pipeline? Fail-fast, yes, yes. If you haven't, or if you haven't decided whether or not to use it, right? Just a recommendation. I'm not saying this is a good solution. That means when you run your PR, and if one unit test fail, you can quickly exit this whole process, saying your PR failed because of one error. You need to fix it. It's actually a good strategy because people get notified immediately, so they don't have to wait for the whole process to finish to the end to fix one error. This actually saves time and seems to be more efficient. But there's always a but. Think about the problem here. Because if your PR takes 60 minutes to run, and if I exit on the first error, what if I have 3 errors in my entire code, or even more? Then that means once I fix this error, then I send another pull request, a new build, and start the process again. I fail again. So the opposite of fail fast is to run the whole thing, get the full report, get everything file, and let the developer to know if there are maybe 5 total failures or maybe 3, so they can fix all errors together and make another pull request. There's no right or wrong answer here. Think about whether or not you want to use it. Depends on how long your PR runs. If you have a PR which takes average over 30 minutes, maybe you want to run them together. But if your code is very efficient and your PR is 5 minutes-ish, it's okay if you want to fail fast. It doesn't cost you that much. So few solutions, things we can do in PR process to improve it is, one of them is your branching strategy. I wouldn't say it does improve a lot, but this will change the design of your pull request a lot. So branching strategy, you have a famous give flow trunk, scale trunk. And I ask this question all the time, is how many of you are using trunk-based branching strategy? That means you have a main branch, and you always commit your code to the main branch. Right. Maybe not. So Git flow is actually, it works really well for mobile application because you have a DevOps branch, and on the other side, you have this master branch or the main branch. You use mostly for release. So for mobile application, you have your developer code, and you have a code mirror on the Play Store, Google or Apple. When there's a bug in your release version, and you must fix this bug, so you have to do a hotfix. And the hotfix comes from the main branch, not the developer branch, because the code base should be the same as your production code. And this is why Git flow is quite popular in mobile industry. And trunk for front-end project is actually quite difficult because that means you don't have a feature branch. You only have a release point, maybe a tag. That means you don't have to do pull request. And in between, we have something similar called scale trunk. So if you are building a web app, or if you have a team having a web developer and cross-platform engineer for mobile, maybe use React Native or Flutter, you might use scale trunk. That means you can cut some of the branches. You will still have a release branch. You will have a feature branch that you want to do pull request, but you might not need to have a main branch. So you can actually do hotfix using a tag or using some version, going back, take the code from your develop branch. So you can actually merge your main branch and your dev branch. So branching strategy, if you define that earlier, this will actually reflect and change the way how you decide to build your PR pipeline and like some decisions like whether I fail fast or not. Your testing strategy contributes a lot to your PR process. That means it's not how you do your test, it's what you want to test in PR process. Do you run unit tests? Do we run the full test coverage? Do we run lint check? Those kind of things that you want to think about in the PR process. But the key here is that we definitely want to separate our code. Again, it would be nice if you do TDD. It will be even awesome, even better if you do BDD. But it's actually quite rare for, like, I haven't seen much in my experience of teams adapted to BDD and the TDD fully. It's up to the engineer themselves whether or not they like or they prefer the style of TDD. But having to go for BDD, it will be a decision of everyone in your team to follow this style. But there will be another completely full talk about BDD. Definitely separate your tests, because once you separate them, then you can pick which you want to run in which environment. So instead of saying, I want to test, but unit test means running the entire integration test, the UI test. So you want to separate them. When you say unit test in PR process, that means just running some unit tests only. We don't have to run integration tests. We don't have to fire up some UI, because running tests with device are super slow, and it costs quite a lot of resources. So in your PR process, maybe you run a set of UI tests, but doesn't have to be the whole, the entire UI test. So your integration pipeline, your PR pipeline, when you merge your code, might look like this one, or slightly different. You clone your code, set up some configuration, and choose which environment you want to run. Either it's end-to-end or into environment, lower environment, right? You pick up your configuration here. And maybe you do some code analysis and to run your PR jobs, either in parallel, in different machine, or you want to run everything like in a very async way in one machine. So if you run them in parallel, it definitely saves you a lot of time, but costs more computer resource. And you want to run some lint check, security check, and here you want to do unit tests, right? Check the test coverage as well. And maybe do some partial testing on UI, not the full, right? So partial testing UI, making some of the smoke testing as well. And in the end, you will have this bundle that you can send to somewhere for people to use, right? Then your code can be merged to the main branch. I need to go a little bit faster. I will talk about full and release here. So full pipeline, in my project, we run full pipeline in a nightly. We don't run them in a day, because a full pipeline takes hours to finish. But we need to run full pipeline because we have functions to support different user groups, right? For example, accessibility, that's actually a key feature that we want to support in the team. So our full pipeline takes hours to finish. Yeah, maybe even more than 2 hours. Here we do literally everything. So our full pipeline is similar with our release pipeline. It has unit tests, integration tests, golden tests, end-to-end, maybe some API as well. Here, I think one key point for this pipeline is for you to think about either you want to run them in the peak time, that means in a working hour, or you run them in the off-peak hour, just to run once in a day to run everyone's code, once everyone merge their code to the main branch. So you actually test everything thoroughly once a day. So things that might change or contribute to the full pipeline design and to accelerate it is whether or not, first, you have where your code base, right? You have a mono-repo or you have a multi-repo. It doesn't change a lot of things, but when you want to pull your code together as run everything in full, you want to actually pull them from different sources, or is your project using mono-repo? That means the code source coming from one place. And also we have this strategy of very controlled code owner strategy. I don't know if any of you are using this strategy here. Yeah, we have to. The code owner doesn't mean it's a person, right? It's a team. So if I change someone else's team in a different feature package, they have to approve this code before I can merge it. And second thing here is your project a multi-platform project? That means do you provide to the end user web, mobile, and maybe desktop support? And this will change slightly of how you design your full pipeline as well, because your full pipeline is not just doing unit test. You want to do more on UI. That means you want to actually running even on more screens and more devices to support multi-platform. So when it comes to release, again, this pipeline, the design of it might be very, very similar to your full pipeline because the testing process is actually very much the same as your full pipeline. Or again, right, this is from my experience. So when it comes to your product, things might change slightly. Okay. And in your project, right, do you have a proper team to look after release management? No? Right. Some projects do have a team to look after release management, to actually spend a lot of time dedicate to release process. If you don't, right, maybe some of the engineer, as you yourself, can step up to be the expert. This team or this person will look after the process of planning, design, and the schedule of when to release and control this process. When I say control, doesn't mean one person says yes or no, but one person monitoring this process. Like, think about how often you want to release and deploy, because release and deploy are separate things. You can actually release 10 times a day, but you only deploy once into your production environment to your end user. But you can continue to push your code to a container registry, and you can release it, right? You just don't have to push out to the end user that often. And how do you do hot fixes, right? When things break, and how do we hot fix them? And in a full pipeline and in release management, one of the things that contribute a lot is micro frontend. So in the beginning of our project, we are a bit monolith. What does it mean? Because we have a project, right? We have different modules and multiple packages, but that doesn't mean our project is micro frontend. Even though we are saying we want to break the monolith structure, but when we look at when we did a dependency analyze, we realize even though we have a feature package, and each feature package contain code for each feature. For example, payment will have their own module. Account will have their own module. Configuration will have its own module. Everything is separated nicely by the folder, right? By the look of it. But our project is not micro frontend, especially when you look at, can we run them individually? Can we run each package individually? Can we release each package individually? We cannot. So our folder structure-wise, they are separated, but each of those folders, they connect to each other very much. They have inner dependencies of each other. That means we don't have a micro frontend project, but then transferring from a monolith to micro frontend helps a lot during release process. And one of the things we benefit from going to micro frontend style is caching. So in the end of the day, our project is not just, the code is not separated by folder anymore. They actually don't have inner dependencies of each other. That means we have, for example, 10 packages which are shared. And if we look at the onion structure, right, those shared packages are the onion, the inner side of an onion. And the outside layer can actually use code from the shared packages, right? But the layer outside of this layer, they actually, so the dependency tree works in one way, right? Doesn't work as both direction. If you draw your dependency tree, and if you realize your feature package connects to a different feature package on a same level, that means you are not micro frontend. You have inner dependency, and it will be hard for you to separate things. So once we took a lot of time clean up the code, make sure each feature package are very much standalone. They don't have dependencies of each other. They don't import from each other. They only import from the core package. So each of our feature packages can actually run as an independent app. And because of this, we can actually implement using the power of caching. And this helps a lot for our release process and the PR process. That means when we run a full build and the test result is cached in our cloud system, next time when you trigger same build, And if your change is only one line of code in one feature package, you can reuse all the testing result from the previous build, and you only need to rebuild that feature package only. So this improves our pipeline, the build time from, say, 60 minutes to 5 minutes-ish. This is a great improvement. But the caching system doesn't work like this, right, solely, because we have to think about dependence and the dependent. So you can use, there's libraries you can use, right? You don't have to build this of your own. And that means if I change one line of code, or maybe 2 lines of code in my core package, and I make a build again, I will reuse as much as I can because everything is is recorded by a hash system. There's a library called TurboRepo. If you are using React or if your project is JS-based, I really recommend you to explore this package. It's open source, TurboRepo. The beautiful things about TurboRepo is it understands your project dependency. So if I change a code in a core package, it will rebuild this core package and everything else that has dependency to this core package. So will be impacted by the change of this package. So we know our code change is safe. It doesn't have any impact or doesn't create more errors. And we don't have to rerun everything together, especially when you have a big project, has more than, 60 packages. So this is really helpful. Because of this, in the end of the day, you are able to release a package by its own version. So you can version, for example, a core package, right, version 1, version 2, and release this package and let other feature package to consume this one as a library. So you don't have to release your product as a one monolith product. This is what I was saying in the beginning. Now, in the previous slides, is you can actually release multiple times a day, version it and bump the version, but you don't have to push this release to a production. You can do that once in every 2 weeks, but you can continue to build, deploy, and release your project in a smaller chunk. So, in the end, how we release and how we enhance it, right? We want to detect error a bit early, and we want to separate release and deployment pipeline. If you are building a mobile application, you want to provide a secure way for testing as well. Make sure your release process is automated and it's short as possible. You can release a smaller chunk of the code instead of release the whole project, right, altogether. You can deploy, maybe that's a typo. You can release a lot of times during a day, but you don't have to push them to the production, right? Just continue to build, to test, and to release. So the pipeline for release is maybe it looks quite similar than the full pull pipeline or the PR pipeline, but what we run underneath them is very different, right? We will get the code, add the configuration. Here, if you are following the micro frontend style, maybe you want to bump version of each package instead of bump version for your product. So your app maybe have a version 1.2, but in the app, you might have a payment package which has a version 2.3. So each of the package and the module can be versioned individually and run the tests as what your team decide to run. And you can then publish it and update the version of the project as well. I don't have time to go through deployment, but deployment can be same as release. But if you separate them, the only difference is that when you do deploy, you don't have to run the whole test again. because this one should be very secure and nobody should actually touch or modify this pipeline. It should be controlled by a very secure environment, maybe having a service account accessing it. So deployment pipeline, if you have this separation, the only thing this one does is to grab the code. You don't have to run tests because everything is wrong in the release process and in your full nightly pipeline. And the deployment is basically get the code. If you are building mobile application, you will sign your APK and sign your app and push this bundle, this app to your production. So say, for example, in the Play Store, in the App Store, and there you go. That this product, in the end, is pushed and distributed to your end user. So this is basically the full process of how you can actually design and configure your pipeline and work as an expert DevOps in your front-end project. Few ways that you can enhance it, right? Code owner is quite helpful. Think about continue to improve it. Run large build in off-peak hour, and always rebase before merge. Those are small tips, right? If you want to consider. So, thank you.